How's the Josh? I know that I'm standing. I think there's one more talk after me, but still on the just before the lunch. So we'll try to make this a little bit interesting. There has been some interesting talks around Gateway API, Ingress, and then Sergey on the software supply chain security. So this should be a little bit interesting, more around on the platform side and how we are basically managing hybrid clusters actually. So yeah, so okay, a bit of introduction about myself. My name is Suman Chakraborty, and I'm working as a solution architect at Platform 9 Systems. So, if someone of you who is not aware of what Platform 9 system is, so we build a private cloud for our customers, which are both SaaS based as well as on-prem based. That basically helps to run both virtual machines and Kubernetes side by side on the common plane. I have been working majorly in advising enterprises around the Kubernetes and DevOps adoptions. I have been a Core CD Foundation ambassador, Calipo Big Cat ambassador, and have been a speaker in multiple conferences.
Hi, I'm Mridul, senior member of technical staff in Platform 9. I work with a team who brings the Kubernetes offering in private cloud director. For the last 5 years, I have been involved in the management and development of such cloud-native applications, and open source has been a big part of it. So it's very special for us to get to share with the community one such tool that we have been using so far and find very helpful.
Okay, maybe a quick show of hands who are working in the DevOps platform side. Oh, yeah, now it's good. So, okay, so let's understand the problem that we are trying to solve. It is about regarding the multi-cluster, right? So, in a current environment, we are not running one form of cloud, right? It's a mix of both on-prem as well as public cloud. And when we say public cloud, it can be anything, whether we are running on Amazon, whether we are running on Google, or whether we are running on Azure. And that cloud typically serves different type of applications. It can be your fintech applications, your basically hosting telco world applications, and so forth and so on. But the real challenge is not about basically infrastructure provisioning. The real challenge is about the add-on automation. So that is what we are trying to focus on our today's talk, which is about the day-to management of the add-on lifecycle. So let's understand where this problem comes. And I have given the name as a sprawl problem, which is an n-dimensional complexity. Think about you are managing. So the complexity ratio that we determine is P into V into R into E. Again, this is not any, I would say, any technical thing. It's just that I'm trying to explain in a more simplistic way where you can think about that you are running cloud that can be on AWS, Azure. You are running on one specific version of Kubernetes, right? And then you have multiple regions where you are deploying this particular Kubernetes. And then you have multiple environments that you are managing on that particular cluster. So what actually brings here? Like, so if you are thinking, okay, we just manage one cluster, that's fine to basically manage the complexity. But when that particular cluster grows beyond, say, 50 or 100, then it brings challenges, which is manual deployments, which are often causes a lot of human errors. There are scripting, ad-hoc scripting, fixing code in a custom way, which basically leads to technical debt managing over a long point of time. And then there is an issue with scaling, which is kind of an operational nightmare for our SRE folks. Now, what happens at the end of a sprint? The DevOps engineers said that हमारे नया plan के मुताबिक, means they always have a plan, but that plan never works, and the manager knows that this plan will never work. So where is the logic gap then in our current solutions? The logic gap here is basically the CI/CD or the GitOps tools, right? Whatever we are currently using is basically has certain issue, and that issue is first of all. we are actually managing the targets as static targets. Like, so it is very difficult to discover clusters which are provisioning dynamically. And then when you are managing hundreds of clusters, then you need to write hundreds of patches to manage them. And the other problem that naturally comes is about cross-cluster awareness, right? So one of your cloud that is running on AWS might not talk on the same language where the other clusters is running, because their driver version is different. You are running two different versions of CNI and so on and so forth. And this basically brings a lot more problems on the engineers, and they are very much sad at the end of the day. It's not only comes on the DevOps team, even it comes on the developer team to actually understand that how they can basically bring a solution that can actually work seamlessly across a different or heterogeneous set of clusters actually. So let's see how we can actually solve this issue with the Project Sveltos.
So the tool we are going to talk about is Project Sveltos, which is a cloud-native add-on controller, and it is designed such a way you can declaratively manage a fleet of cluster and all the add-ons in it. So it started as a side project of a principal engineer of Cisco, who is Gianluca Mardente from Italy, and it has grown over time and has a vibrant community around it. So think of it as a automated logistic hub where you do not have to tell each truck driver what to load on each and every truck. You just simply label, and whenever it pulls to the loading bay, the hub already knows what to load in the truck, right? So we'll try to understand that how Sveltos work with this diagram. So the flow starts from defining your configuration and application in custom resources named profiles or cluster profiles, and the Sveltos controllers continuously watches over your fleet of clusters, and as soon as some cluster joins your fleet with a certain level, it determines what to install on them. So you get dynamic watch over it. Well, you have a cluster API covered cluster, it gets auto-discovered. Otherwise, you can manually register a cluster using admin qconfig. Then there are always a part of the event-driven automation where, based on certain events, your controller can decide what kind of application needs to be developed. If there is any health check failure, it can deploy remediation or run some kind of scripts. So there are multiple components. So let's categorize them into these categories and associate them with the day-to-day questions that we face during solving such deployment problems. So when you need to define what to deploy, you write a cluster profile or profile, and when you want to determine something based on the events happening on your managed cluster, you have to define event source or event trigger to tell the management plane what to do in response of that event. Then the labeling of the cluster can be automated through the classifier, and last but not least, you have templating as well. So in case of multi-tenancy, you cannot write same template over and over. So you define a static template which can be instantiated runtime based on the unique metadata of your cluster.
Yeah, so as Mridul explained, the core components that belongs or that is part of this Sveltos is something which we define as a cluster profile. So it's nothing, it's basically a custom resource definition, and what it basically tells that how you are going to manage multiple clusters under the hood, right? So basically what it defines is something called as a cluster selector. Now, cluster selector defines what are the different clusters that you are going to manage. As you saw in the diagram, there can be a cluster which is deployed on Civo. There's one cluster that can be deployed on maybe on Rancher. There's a cluster that may be deployed on GK, AKs. There are different varieties of clusters, right? And the second is a Helm charts, which is nothing but a list of Helm charts that are deployed in the clusters, that will be deployed in the clusters that matches that particular selector, right? So this Helm charts define what kind of add-ons or services you are going to install. And the next is a customization reference. So Sveltos give you the possibility where you can actually integrate that with your existing GitOps tooling system. So you can actually not only deploy the clusters, but deploy the complete application stack on that particular clusters. And the policy reference is something which basically helps you to define what kind of different configurations that you are going to run on that cluster, such as config map secrets, right? Now, when we define the clusters profile, it is more at the cluster level. But let's say you might have a requirement that I have multiple tenants to manage, right? Because nowadays the important thing is about multi-tenancy. We are segregating our customers onto different namespaces so that they are completely isolated from one another and they should not know what the other customer is deploying or doing something, right? So that is what profile helps us. So here, Sveltos sits directly on your managed clusters, and if you have, let's say, deployed Kapi as a cluster API project, Sveltos automatically detects your managed clusters and deploys your add-ons on top of it. But let's say if you are selectively want to manage certain add-ons on certain namespaces, which are defined as tenants, then there is something called as a profile construct, which basically helps you to do that. We'll have a demo, we'll see more about it. So now coming into the actual use case where Sveltos actually helps. First is the dynamic cluster management. Let's say you are managing a fleet of managed clusters together and you deployed your add-ons on top of it. Now what happens if a ROG engineer comes and deploy your certain add-ons, right? Certain services without doing anything. Now Sveltos under the hood basically does something called as a cluster say. It basically understands that which clusters it is managing, what particular add-ons is installed. If it detects that something has changed there, or let's say basically if particular clusters becomes unavailable, so it will basically create that another clusters and deploy all the services that it should have done. The second use case is about the configuration drift detection, which is very important in when we are managing a hybrid cluster base. So Sveltos has a mode which is configured as continuous with drift detection. What it does, like when you deploy Sveltos, it detects something called as a detection manager onto your workload cluster. Now these are all custom resources that gets deployed, and so there's nothing extra services that you are deploying. What it does is manage all the states that you are running on the clusters which Sveltos has defined, and based on that, it takes certain action. So in this case, let's say you have deployed one add-on such as envoy proxy, and that particular envoy proxy gets manually deleted. So Sveltos will automatically run a loop, a reconciliation loop, to understand that this particular envoy is not present. It will go ahead and deploy that. The third is about the cluster labels. This use case is basically targeted for those environments where you are running different versions of Kubernetes across different fleet of clusters. Not every Kubernetes version will have the similar spec requirement in terms of the add-ons, right? So in this case, you can specify using classifier to deploy what versions of that particular add-on you are going to install on what version of Kubernetes clusters. So that is what this is. So we will see through a short demo to understand more about these uses.
Okay, so demo time. Wish us luck.
Hope demo boards are with us.
Okay, so let's start with looking at the management cluster. So for that, I will list down the applications that I have installed in the Project Sveltos namespace. So the charts that I have installed are Project Sveltos and the Sveltos dashboard. It has all the pods and the controllers running on the Sveltos namespace. So we will look at 3 use cases if time permits, and we'll understand their responsibilities. So to see how the application deployment can be automated, we're going to create something as classifiers. So let me show you the cluster profile. So let me show you the cluster profile first. So I'm going to create 2 cluster profiles. I will highlight this three sections here. So one is the cluster selector, which says that if in your fleet some cluster is tagged as UAT or QA, you go ahead and deploy a HTTP app, and this is the health chart reference and the custom values. Along with that, it also shows you that it depends on another cluster profile, that is the ingress. And you can see the ingress definition is here defined. So I'm just going to apply the cluster profile, and let's see what happens. Okay, so the cluster profiles are created. Now let's check out our clusters. So I'm listing the Sveltos clusters here along with the labels. So as you can see, we have two Sveltos clusters defined here and registered along with the dev and QA label. So as we have shown, the QA cluster should have these two applications installed. Let's look at the status. I'm listing down the cluster profile and checking the status of the demo HTTP bin app. Okay, so it has the match level cluster, and also I'm checking the cluster summary to see what is the status of our deployment. Okay, it says that the ingress Nginx is still getting deployed, so it takes some time to get the load balancer IP and fully make it ready. So meanwhile, let's look at the dashboard.
So Sveltos provides a easy to reference dashboard, which basically helps you to highlight that if you're running, let's say, a wide fleet of clusters, what kind of different add-ons you are actually running on those clusters. So that dashboard is, I would say, you cannot actually do much write operations on that. It's more for the UI visibility to understand what are the different add-on versions running across your fleet of clusters, but that is quite helpful in terms of gaining a complete understanding of your infrastructure topology.
Okay, so I have port forwarded the service, and I'm going to use this token from the service account that I have previously set up. And before pasting, I'm just going to hard reset. Okay, so currently we have these three clusters registered. And when I go to profiles, I can see the two profiles that I have just deployed. And if I check the status, we see a nice service graph which says it has been matched with a cluster and has been provisioned successfully. And as a dependency, the ingress Nginx app has also been provisioned. So let us check how we can register a new cluster. So I'm going to bring another cluster. And to register, I will use the Sveltos CTL, their command line tool. So, yeah. So the register command has this following arguments where I can define a name, the kubeconfig, and also I am labeling it with environment UAD. So the cluster has been registered successfully. Let's check out the list of our clusters. Yeah, thankfully it got registered very quickly. Sometimes it may take time, but as you can see, we have three different clusters of three different versions. And yeah, so that was the first use case. For the second use case, I'm going to show you how we can automate the labeling of the cluster using classifier. To do that, I am showing you a demo classifier which says if I have a Git application of two different versions, I would like to deploy the older version on any cluster that is between 1.31 and 1.33, but any cluster that is above 133, I would want to deploy the new version. So for that, let me deploy the cluster profile first, as we showed in the first example, and then we'll be using the classifier to automate the labeling part. All right, so the classifiers are getting deployed now. And I am going to deploy the cluster profile as well. Let's look at the Sveltos cluster labels. We can see that the older clusters that are UAT and dev with version 133 and 131 and 132, they got the older version of Git T, but the other one got the newer version. And we can confirm it from the dashboard as well. So if I refresh, let me do a hard refresh here. Right? So we have a new cluster registered from the last use case, and we also have this two application that says that is admin deployed in UAT and dev. So yeah, we have another use case. So I will go, since we do not have much time, I will go about it quickly. There is another powerful feature called event. So whenever some event happens on your managed cluster, you can do a particular step or remediation on in response to that. So I have an event source defined here, which says that look for any cluster that it says if any service is created with this following label, Sveltos FV, you go ahead and create an event. And we can see that currently matching cluster we have one matching cluster, but no resources found. So I'm going to go over the target cluster and create something quickly so that the event gets triggered. Changing my context to dev cluster. Okay. As soon as I create the event, I'd like to show what I have defined in the event trigger. So the event trigger says whenever that event source is triggered, you go ahead and create a network policy which is referenced from this particular config map. And here comes the power of templating. If I show you the config map, you can see it takes out the unique metadata of the cluster and creates a resource out of it. And if I go to the dev cluster, I can see that in response of that event, network policy has been deployed over there. And yeah, let's conclude our demo with that. And yeah, dashboard also shows that the resource has been detected, and we have the like effect deployed over there.
So we actually actively use Sveltos in our platform 9, the product actually, ECD. So here we are basically managing the clusters as with actually add-ons versions, and that is what we are doing. We are actually deployed CAPI, and CAPI automatically manages all the components within the workload clusters, and through Sveltos, we are basically managing the services that need to be deployed on these managed clusters. So how does Sveltos then differentiates between other core technical services that are available, such as standard GitOps or CI/CD tooling? So Sveltos relies heavily on the label-based process. It basically does everything dynamically. It has an event-driven CRT process to take care of all the dependency logic that it is currently running across all the fleet of clusters. It has a full lifecycle auditing of all the management of the clusters, and then it is completely cloud native. However, you bring any clusters that are different that are coming from different providers, it can automatically manage them based on any other specific resource configuration. So what are key takeaways? So first is like we need to shift our mindset from clusters to labels while using Sveltos as our codes. We don't need to really worry about how the cluster configurations need to be done. Event-driven orchestration goes beyond the simple file syncing process that we normally do in a GitOps-based approach. Built-in threat detection and self-healing is one more capability that is provided, and everything that we are doing via the Sveltos is via a programming interface. Like we tag a particular cluster with the label, Sveltos knows that this cluster is present, and it basically runs through all these changes, right? So I think you are all now like adding. So here you are completely aware of what's going actually, right? So these are some of the references that we have used to build our talk. And yeah, so this is all about Sveltos. And if you want to know more about us, you can connect us. This is the handlers. So would be like to get in touch with all of you to understand your use case and best way to suggest how you can manage Sveltos, because we have been using Sveltos practically within our product ecosystem, and we have definitely found it very useful, specifically when we are doing different upgrades of our clusters. We now need to rely on what is the add-on versions we need to install. We just given a common spec to the management cluster via Sveltos, and it does everything programmatically. So that headache is completely gone from our side to manage our environments on private cloud directories. So any Q&A that... Okay, so I think we are almost up the time. So we are here, so you want to connect? We'll be there to take any more questions on this topic. Thank you.
Yeah. So thank you so much for simplifying the multi-cluster automation for us. And we have some token of appreciation for you.